Okay, I think we are live.
Just a second.
Oh, sorry. Yes, timings. Okay, I think we are live. Okay. Hey everyone, I'm Shivlal. I'm a new guy here in this Azure community, along with some more folks. And we are going to talk about the college to Azure session. And we will talk about basics of cloud and all other stuffs. And we also have an awesome guest, an expert speaker with us, Divyasam. He's a full stack developer at one solution, and he has a good amount of knowledge in this field, and he will share his knowledge with us. So over to you, Divisam.
Thank you for the introduction. And and today we are going to learn about Microsoft Azure fundamentals. So before we start, let's set the goals for today's session. We'll start with what is cloud computing, some basic briefing about that. And once we learn what is cloud computing, then we can see what are the disadvantages of not adhering to cloud computing, like if we use on-premise solutions. Then we'll learn about how Microsoft Azure comes into this picture as one of the leading cloud providers. And then we are going to create a virtual machine and deploy a hands-on project into that. So let's start with that, right? Let me share my screen. Cool. And during the session, if anyone has any doubts, feel free to post it in the comment section. We'll be looking for that. All right, so I hope my screen is visible. And okay, so before we jump directly into Microsoft Azure fundamentals, we must know why at first place do you even need uh, cloud computing? Do you even need Microsoft Azure? Like, what's wrong with your own system where you have already developed your software, it works fine, then why do you need a remote cloud, right? There must be n number of questions inside your head, like why at first place do you require a remote cloud system? Why is it even called cloud? So to talk about few, let's talk about an example, and with that example, we'll see when you require cloud computing and how it comes into the picture. So think about that you have a working application. Let's say you have built an e-commerce website like Flipkart or Amazon, and you have built it completely. It works great, and it works on your system. So it works perfectly on a system. So now you are ready to go live and launch it globally with the name, let's say dinoshopping.com. So you get an IP, you start your website live from your system. And now your business is small, it has around 5 users, so it works fine. People use your application from your system. Your application is connected to the network, and through the internet people are using it. Let's say dinoshop.com, people are using that, it works fine. Because today you have 5 users. Now you think of expanding your business. So the next day you do some promotions. You use newspapers, you use Instagram, Facebook, you use all kinds of social promotions. And the next day, let's say, somehow miraculously you get 1 million customers. So do you think your system can handle the load of 1 million customers? No, right? Like when the real world data starts flowing, no single system can handle that kind of data flow. And here I'm just assuming that your system is completely resilient. When this kind of flow happens, the system might just crash due to the load. The system might just um, go do a reboot because of this load. Even the network might crash because it cannot handle that kind of load. And if your system crashes, you lose all the data of your existing customer base. And how do you get back your data? So there are n number of problems that might happen if you launch a full scale application on your laptop. one something that can happen, the worst kind of situation is, let's say you run out of memory. Like, for example, to give you a gist of what kind of data a real world application generates, we all know Shopify, right? Shopify is a famous shopping website. So in that, during this last month, during Black Friday sale, Shopify witnessed around 40 more than 40 petabytes of data flow per day. So per day, 40 petabytes of data was flowing through the system. uh, and 40 petabytes is like 1024 terabytes, and 1 terabyte is 1024 gigabytes. So you get the idea what kind of data flow happens. So imagine you have your system, and some kind of sale happens, or you have done some promotion, 1 million or multitude of people come in, and you instantly run out of storage. So how do you get more storage into your system? Are you going to uh, get and are you going to purchase a new SSD or a new external drive, and you attach it, and okay, you do something, you increase the storage and it works fine. But for how long you can do that? You're instantly going to run out of that SSD again. So how do you make sure that you never run out of storage? How do you make sure that your system never crashes? How do you make sure that even if you lose data, your data is recoverable? You can recover it soon. How do you make sure that network never crashes? All these, if you think about all these things, these all things are associated with the physical properties of your physical configuration of your system. Storage, network, data crashing of the system, all of these things can need to be maintained physically. And that is where cloud computing comes into the picture. So you don't run your project on your system, rather you place it on a you run it, or the runtime is actually a remote system in a managed data frame. For example, Microsoft Azure. So Microsoft Azure, from their data frame, it will allocate you a system which is virtualized. So this is not a this is not like a complete system with a monitor and attached accessories and stuff. It's a virtualized system, just like when what you do in, I think, VirtualBox. You must have used VirtualBox, running separate operating systems within your own machine, that kind of thing. So it's an example of virtualization. So that's what happened in a cloud. That is what happens in a cloud, data frame, in a data farm, or a server farm to be specific. So let's say in United States or in Mumbai, there is a server farm of Microsoft Azure. So inside that, there is a huge system which has a really good configuration, and it is attached to a network of computers. So it has access to huge amount of storage. You can basically say it's virtually unlimited amount of storage and compute. Now, through virtualization, you can get any kind of flexible configuration that you want. And now let's say your business expands and you want to get more storage. So you don't actually have to buy the storage. You actually just have to get a subscription for a better storage plan. Let's say you think that your system is unable to handle this kind of load. So you go ahead and get a better configuration, like a better processor. You can upgrade your processor on the go. You can upgrade each and every individual configuration of your system on the go. That is what virtualization means. And that is where that is one thing that we are going to see today, a virtual machine. So a virtual machine is something that you get within from a cloud provider, a very basic concept. A virtual machine is the most fundamental cloud computing resource that any cloud provider can provide you. For example, in Microsoft Azure, it goes by the name Azure Virtual Machine. In AWS, it goes by the name EC2, Elastic Compute 2. In GCP, it goes by the name Compute Engine. So names are different based on their marketing or branding, but at the end, it all comes from a core concept of virtualization. Virtualization allows you to get a virtual machine with your own flavored customization, your own any kind of thing that you can basically imagine. You want two cores in your CPU, you can get that. You want four, you can get that. You can configure every single thing inside it, and you get the access to it. You can run anything you want on that system. So that is what is called a virtual machine. And here's a book's definition. A virtual machine is an on-demand, and we know it is on demand because you don't need to basically you know purchase it, set it up, or basically worry about it at all. It's managed by your cloud provider and on demand through Microsoft Azure portal. You go to the portal, you set some. It's as easy as getting downloading a movie from Netflix or getting a subscription on Netflix. Like for example, imagine you want to watch a new movie whenever you want to. Whether it's 10 p.m., whether it's 10 a.m., whether it's 12 o'clock in the midnight, you just go to Netflix and you get the subscription and you watch the movie on demand. Notice the word on demand. Similarly, on virtual machine, on Azure virtual machine, or basically any cloud provider, this is what on demand means. You can get the system anytime you want, anywhere you want. I said anywhere because you can also select the location where your actual server is located. Mumbai, US, Europe, so to name, there are lots of regions. And then it is scalable. So scalability is another feature that you get from a cloud provider, and it is managed for you. You don't have to worry about scaling if you go for a managed service. And you might ask, what is scalable? So for scalability is typically of two types: horizontal scaling and vertical scaling. But let's understand it with a very basic example. So let's say, let's go back to your e-commerce example. You have a website called dinoshop.com. Today it has 5 users. Tomorrow you did some the other day you did some promotion on socials, and now you have 1 million users. It's magic, right? That's how Shark Tank works. So you have 1 million users now. Now your single system cannot handle 1 million users. Not even the virtual machine that you get from that you get from your cloud provider. Even one single virtual machine cannot handle 1 million users, right? So scalable makes sure that, let's say right now there are 10 and the next second 20 users are online. So it will distribute the load among them. It will create a new virtual machine because it's on demand, right? So let's say a load is increasing. Right now it was 10 and the next moment 20 users came into your e-commerce. So it will instantly create a new virtual machine, because on demand basically you can create as many virtual machines as you want. So instantly it creates a new virtual machine and balances the load between the two machines. So let's say you get 1 million users, and suppose each virtual machine has only the capacity to handle 10 users. So instantly what you do is you go ahead and create uh, 1 lakh virtual machines. It can scale up, right? And each virtual machine just now has to handle 10 people. So that is how scalability happens. It creates new instances of the virtual machine and distributes the load. I'm giving a very rough example, a very layman example, but this is how horizontal scaling works. And there is something called vertical scaling. What this does is it increases the resources available to your system. Let's say this system is unable to process the current load, so it will get it more virtual processors, get it more storage, more RAM. It will increase the configuration, make it more monstrous. So that is what vertical scaling is all about. And in general, virtual machines are generally used to host applications where the customer requires more control over the computing environment. Now uh, this is what a virtual machine gives you. It gives you the flexibility to handle all kind of low level details. So let's see. The statement here says that you get control over all, like the most control over most low level control compared to all other computing resources. So let's see what are the other computing resources, right? Cool. If anyone has any doubt, please let me know in the comments. Now let's go to the Microsoft Azure portal. And yeah, I think you all already know how to get a free subscription. Go to the Microsoft Azure, go into try Azure for free, start free, and make sure that you have already used GitHub Student Developer Pack to get a free account, right? To get some free credits. So if you go to GitHub Student Developer Pack, here you can find something called Microsoft Azure free credits. Let's say we go to Student Developer Pack, sign up for Student Developer Pack. Well, I'm already signed in. I don't need to do that again. Here you just need to sign in with your GitHub account. And if you go to Intro to Web Dev, scroll down, and there you go. You get $100 free credits in Microsoft Azure. Apart from that, you can directly use this Microsoft student benefit on the Azure portal. You just need to use your college email ID. So I'm going to use existing subscription, and in the billing you can see that it's enabled by default if you use your college email ID. Well, we can pull up the billing later. Yeah, okay, so it came up. Cool. So yeah, you just need to make sure that the billing scope is enabled, and once that's done, let's go ahead and see what kind of different computing services are provided by Azure. So virtual machine is what we are going to learn today, and what we just saw that it provides the most low level flexibility in entire computing resources available. So there are other kinds of computing resources available as well. For example, there is something called app services. Now, app services is something that you would use when you have a very simple job to do. Like, you don't need to you don't want the flexibility of controlling the entire virtual machine. Like you have control over basically an entire operating system. You can do whatever you want, you can install whatever command line application you want, and you can do everything. Like, you don't have to but here in virtual machine, although you have the flexibility of controlling everything, but it's also kind of a headache, because you have to install the dependencies, you have to get the packages, you have to get whatever your software needs, you need to set up the entire environment, and then you use a virtual machine. But if you use an app service, this is very managed. Here you don't have to worry about a lot of things. All you need to do here is provide your code. You just provide the code, and you manually say that on the UI what kind of environment it uses, and that's it. It will manage everything. It will manage scaling, it will manage security, it will manage to go ahead and download all the dependencies or libraries that your software is using. It will do everything for you. You don't have to worry about anything here in app service. In virtual machine you have control over everything, but you have to also manage everything. Now there is something called container instances. If you want to run your own container workloads, like, you must have heard about Docker is again a container open source containerization application, which allows you to uh, not only ship your source code, but also the environment in which you built it streamlines the environment and eases development a lot. So Docker is something very interesting, and you all should learn about if you want to go into application modernization. Docker is really cool thing. Then let's say you have multiple Docker containers running. You have something that uses a lots of microservices. So Kubernetes is something that you would use for computing. It will handle the manage those containers for you. So I'm just giving you an overview about the different kind of compute resources that are available. There is a plethora of services. Even I have not used all these things. Virtual machine is something that is used very frequently, and that's what we'll see today, right? So let's see what we can do with a virtual machine. So yeah, more or less that is what was present here about virtual machine. And during a virtual machine you get the flexibility of virtualization without the need to buy or maintain any underlying physical hardware, and that is what we already discussed. You don't need to worry about purchasing new resources for your system, or maintaining the resources, or updating the resources in future. By resources I mean the amount of RAM that is available, the amount of storage, the kind of processor that your system is running, i3, i5, 7, Xeon, anything. You don't need to worry about any physical hardware. All of that is managed and maintained by your cloud provider. And of course that's one of the key benefits of um, using cloud native products. So that's in a short all about a virtual machine, and now we are going to create one and deploy an application there. So for today's workshop I've created a sample application. I'll share this link with you guys, so you can clone this repository remotely on your systems, and then we are all on the same page to get started with. Right. I hope someone can share this in the YouTube chat. So now let's see what is the project is all about. Let's first run our project on the system. Let's see how it works, and then we go ahead and deploy this in Microsoft Azure. And what's the benefit of deploying on Microsoft Azure, you might ask? So of course, the first benefit is now it's not running on our local system, but it's on Microsoft Azure. So it's scalable and it's managed, and it will never be down. It will be reachable every time. But apart from that, um, another benefit of deploying your projects on any cloud provider, today Microsoft Azure, is now, for example, you build a future project. Let's say it's your personal project, or let's say you've participated in a hackathon. Now you don't just have to give presentations from your system that this is how the application works, this is what it looks like. And let's say you want to add this application to your resume. So you don't have to write a description in your resume like, this is my project, this is what it does, the features are this is XYZ, and I learned these things from this project. Apart from that, you can give the live deployment link in your resume. So whoever is reviewing your resume, they can directly go to the link and use your project, because now it's deployed, it's a live project. And this is, whatever kind of, however well you describe it, if someone can actually use your project, it gives 10 times the better impressions. So after today's session, I hope you all get some insight about how to deploy projects, and how Microsoft you can leverage Microsoft Azure to deploy your projects very quickly and make it go live, and make it accessible for the entire world to use, not just on your system. So to get started with today's project, I'm sharing a boilerplate application with all of you, so that all of us are on the same page. And how to download this application: if you open up the link that is shared with you, this is where you will be. If you click on code, you can just download the code right from here. If I click on download zip, the entire file will be downloaded. Or if you have GitHub installed on your system, so if you have GitHub installed on your system, you can just write git clone and paste the link that I just shared with all of you, right? Git clone. Okay, git clone and the link that is shared with you. Once you do that, it will download the repository and open it up on your system. I already have it, so I cannot clone it again. What I'm going to do is I'll go into the project directory. So now this is what the project looks like. Okay, so it has, you don't need to worry about the program that the code that is written here, because today's session is not about writing server side code, it's about deploying servers into cloud. So typically, that the job of a cloud engineer does not involve writing backend or server side code. It's written by the backend developer. Your role is to make sure that this application runs fine on the system. And how do you know, how do you make sure that your application runs fine? You need to make sure of two things. One, whatever environment this application needs is available in the virtual machine. Second, you need to make sure that your all the security rules and all the configurations are fine for the system to be accessible by the world, basically by the virtual, outside the virtual machine. So that's all we need to worry about, because today this session is about cloud computing. And you, all of you, imagine that you are the cloud engineer, so you don't need to worry about this code. We need to make sure that this runs on the system. That's all. So let's not dive into the code. I'll just show you what the code does, and then we deploy it. So there is a file in the project called as package.json. Package.json has a list of all the libraries or the dependencies that this project uses. So we just need to make sure that when we deploy this on the virtual machine, all of these libraries are installed. And how to install all these libraries? If you have Node.js installed on your system, you can try this out on your system. Or now, don't worry if it doesn't work, because not everyone uses Node.js on their system, right? So when we deploy this on the virtual machine, you can directly try it out there. There it will definitely work, because we'll set it up. So just to show how to set up the project, first we write npm ci. This will go into this package.json and install all the files that are mentioned. So it did that. Went ahead and installed all the files that we wanted. Now we just write npm start to start the project. Yeah. Once you see this message that server is now listening, we can do that. So I'm just going to click on this link, and okay, so the project opened up in your in the Chrome browser. Now, before we dive into the project, I just want to give you make you notice something, that the current domain, or the current IP address where this project is running is 127.0.0.1. So 127.0.0.1 is a very special IP address because this does not correspond to any external IP. 127.0.0.1 always is like a self address or a loop back address. Technically, it's called a loop back address. So, what a loopback address will do for you is basically whatever you write in next to this IP address, those addresses will be searched for in your own system. Now, on port 8080, our software or the backend port is running. Basically, a backend requires a port where it accepts request. You know, so 127.0.0.1 is our local host address, or it's our own machine, and port 8080 is where our software project is running. And inside that, there is a URL register which shows us what we are seeing right now. It shows us a form. So in here, this application does a very basic job. Basically, you provide it an email address. Let's say I give example @email.com, and then I give it a name. Let's say unicorn, and we choose a profile picture. I need to find a good one. Downloads. Okay, I have a unicorn image. Okay, all right, and you sign up. The moment you sign up, you will get a confirmation, a tick, and a good job. Good job, unicorn, right? And now if you go to this explore button here, you can see a list of all the people who have signed in. Unicorn example @email.com, whatever we submitted into the form, and the profile picture that we submitted. So that's all this project does. A very basic project. It stores some data and shows us the data on demand. Now we want to make sure that this project is available to use on the internet and not just on our system. Like, we don't want this 127.0.0.1 IP address. We want a public IP address, not our system's IP address, because this address is not reachable by others. Like, if you try this web address right now on your system, nothing will come up because nothing is running on your system. When you write this IP address, basically your system will look into its own ports, not my port. So to to make the software accessible, we need to run it on a cloud provider, on the virtual machine of a cloud provider, to make it globally accessible. So how to do that? First things first, we just saw how the application works. Did I just close it? I didn't. Okay. So to make the application work, first of all, we are going to create a virtual machine. Once we have a virtual machine, we can run our project inside it. So we already discussed how to get a Microsoft Azure subscription, the student one, come in and go into its dashboard. So now we are going to go into compute engine, a virtual machine. So if you go to all services, you go to compute, and we go to virtual machine. In here, we have an option to create a new machine. And before I create a new machine, are there any doubts right now? Cool. It's a local host address. Exactly. Technically, the 127.0.0.1 is called the loopback address. Or yeah, in general, you can also type the local host on your browser to directly ping into that IP namespace. Okay, so we click on create and we click on virtual machine. Now I'll walk you through how to create a virtual machine. Basically, it's we just need to follow the on-screen instructions, but I'll tell you what this instructions basically do. So first, subscription is our Azure for students, and it covers virtual machines, so we don't need to worry about it. Then we need to select a resource group. A resource group is nothing but a namespace under which you can group all your resources that your project is using. So let's say you're using a virtual machine, you're using some disk, you're using some storage, you're using some security protocols. All of those will be under one name, so that later on aggregating your projects are easy. So I already have created a resource group. I have named it Azure Workshop. That's what I'm going with. If you want to create new one, like if you first time using the Azure portal, you might not have any resource group. So create a new one. It's very simple. Just type a name and click OK. Like it doesn't need any configuration. It's just a identifier, a name. Now we are going to give a name to our virtual machine. I'm going to call it Node.js profile, because that's what our project is all about. It stores the profiles for different users. Now we're going to select a region. Now you don't have to worry about the region, because now we are doing it for learning purpose. In production or in enterprise, when you create a virtual machine, we normally select the location that is closest to our clients. Like if our server is for India, we want to make sure that if our clients are from India, we want to make sure that the virtual machine is also running on India. And then you also have to keep in mind, when you're doing this for an enterprise or an actual real world company, you also need to keep in mind the cybersecurity laws, the data laws, and the data privacy laws. Like there is some that European law says that your application, whatever data the client is providing, whatever application is running on any server, but if it has any European users, their data must never leave the European country. Like you have to run the system, the server, the database, everything within Europe. So sometimes the laws define it, sometimes there are company policies, and those things, based on that we select a region. But today it's for a learning purpose, we don't need to worry about it. I can just say Asia specific, Pacific, Central India. Then there are availability options. You can keep all of these things at their default. Image is interesting because image allows you to tell the virtual machine what operating systems should be installed on it. You can, for today's session, you can use 20 and 18, any Ubuntu, that's going to work fine. Then there is Red Hat, Oracle, CentOS, Debian, Windows Server, Windows 10 Pro. You can basically install any any operating system on your virtual machine that will be allocated to you. Totally up to you, whatever you want to use. Now size allows you to configure what like how monstrous should be your system. So if you go to all sizes, you can see there are lots of virtual machine that you can use. So for comparison, I'm just showing you the screen. This if you go with this machine called DS1V2, it has one virtual CPU, it has 3.5 gigs of RAM, it has 4 data disks, max IO input output per second kind of thing. Then there is a temporary storage. The temporary storage is known as swap memory. This is what will be used if you run out of RAM. Now there are premium disk supported, that is you can use SSDs. So there are lots of these configurations available. Like this system DS3V2 has 14 gigs of RAM, better in IO, better more swap memory, and all those things. So if you go really down, you can get some really cool systems available to yourself. So there are lots of configurations to choose from. It's based on your what kind of stack your project is using, and how huge is your how massive is your client base, how many people are going to use it. On basis of that, you choose these kinds of configuration. If you are doing something related to machine learning, none of these systems are going to suffice you. You would like to get something that has a graphics processing unit, a GPU attached to it. So those are some things that we need to keep in mind. And I'm going to go back to create a virtual machine, and I'm going to use the most basic one that is available. Not the basic, not the most basic, most but second basic. It has 2 virtual CPUs and it has 8 gigs of RAM. This will suffice our today's project. Now this is important. Authentication type, set it to SSH, because this is how you will access your system. Give it a default username. I would recommend give it your own name. A default user, like if anyone has ever used Ubuntu or any Linux based machine, you're normally all inside the home folder of a default folder will be created for you, and your users will be given some roles. And yeah, basically you can keep it at its default. That's what the username would be. You can verify your own username on your system with this who command. It will tell you who is the current user on the system. So right now I'm going with my own name. SSH public key source, keep it at generate a new key pair, because this is the first time we are creating a project. We don't, I suppose we don't already have any previous projects, any key to access our systems. And give your key pair a name. We'll later on see why this name is important. Now make sure that all the protocols are allowed, because our Node.js uses HTTP protocols. Then we go to disk. Operating system disk type is basically what kind of storage is available. There is SSD, premium SSD, standard SSD, and hard disk. Well, we are on student subscription, so we don't need to worry about money. It's free for us, so I'm going with premium. But today's project does not use any, that is not dependent upon read write speed. So you can basically use any storage you want. You can choose what kind of encryption you want on your system, on your disk. uh, you can keep all these settings at its default. Next we go to networking. So these are the networking configurations available. For now you can leave it at its complete basic. Let's just enable RDP, remote desktop protocol, although it's not necessary. But yeah, these are the 4 different protocols allowed on your system. And for now we are going to leave all of these settings at its default. We are not going to change them. We'll change them later when we figure out what is the problem in this current configuration. You can opt for load balancing if you want. Load balancing is what enables you the scaling. Load balancing will keep a track of the load and scale your system based on the load. So today we don't want a load balancing group, because this is for learning, and we can keep that settings at its default. You can go for default for these settings. These are some extra kind of configurations for advanced logging, accessibility, etc. Now this is another kind of login that you are allowed to do. Azure AD, or also known as Microsoft Azure Active Directory. Active Directory allows you, kind of authentication or role based access to your system. You can assign roles to who can access and who cannot. But today we are the only person who is going to create and use, so we don't need these settings. Then there are some advanced selections. We don't need any kind of configuration here for today, but this is something you can use. Custom data and cloud init. Here you can write any kind of cloud data or any kind of script, which should run every time your system boots up. It's like a remote configuration if you want to. If your application has some sort of need, you can use these things. We can skip to the next section. Tags allow you to give a unique identifier to your machine, so that you can it's easier for you to find the system when you want to later on. So I can say that the purpose of the system was Azure Workshop. So it's just a variable. You can choose any key and any value. It's totally up to you, however creative you want to be with naming, so that later on it's easier for you to find. At the end, you will see that the validation has passed, and you have to create and download the key pair. So to download, you will get a pop-up. Let's hold on for a while. Okay, so you just download the key pair, and this key pair is very important. Through this key pair, you will be able to access your system. Are there any doubts at this point? No, mate, no doubt. Where to learn about these laws? You can learn about these laws on well, you need to google about data laws. The most globally accept no, I won't say the globally accepted law, but the law that is most complete is the GDPR law or GDPR law. I think it's something that the Europeans have created. I think it's called GDPR law. GDPR law, yeah, General Data Protection Regulation, GDPR. So here you can learn about all the details and all the policies that it has. It's called GDPR law. It has not come to India yet. It is only right now applicable in the European countries, and that is why European countries feel so secure right now, because it regulates the complete data flow. If GDPR comes to India today, a lot of companies will need to rework on their data policies and their technical stacks. So GDPR is something that completely defines where the data should be available, who should be able to access it, and what kind of security should be there, everything. So now, okay, our system has been created. Deployment is complete. Go to resource. So when your system is allocated, these are the details that you can see on your virtual machine dashboard. Here you have some quick controls. You want to connect to the system, you can do that from here. You can restart your system, you can stop your system, you can capture the current configuration of your system or the current state. You can delete your system so that you never have to pay for it again. It's deleted, no resource will be used. This is for refreshing the page, open in mobiles, command line interaction, PS, all those things. This is important. The properties section. Here you can see all the configuration that is attached to the current system. Here you can see the networking, and this is important. This is how you will access anything running on your system for now, unless you have a domain or you want to attach domain. But we are not going to use a domain because it's something that you need in a very later part and it's not necessary. So using this IP address, you can using this public IP address, you can reach out to anything inside your system. Right now this cannot be reached because there is nothing running on the system right now. So let's run something inside our system and then we can utilize it. So to connect to your system, click on connect here, click on SSH, and copy this command that is available to you. Now I'm going to copy paste this command. The syntax of the command is pretty simple. It uses the SSH command line tool, and then we pass the path where we downloaded this Node.js profile.pem, or whatever you gave the whatever name you gave to your virtual machine, that plus .pem, whatever file that was downloaded in the end. .pem is what is its extension name. So this has all the configurations and all security credentials to access your system. And this is the syntax of the command. Your username at the date, the public IP address of your virtual machine, and that is how you can get into the system remotely. So now I'm going to give it the path to the security.pem file. So the name is, I forgot the name again. It's node.js profile underscore something, and it is in my downloads folder. So I'll say downloads node.js profile profiler underscore key dot pem. So now if I hit enter, you need to type yes because that profile key will be added to your system. But it fails. The reason that it fails is it currently considers this file as not secured. Did I use the right file? Let me make sure. The complete name of the file is node.js profile underscore key dot pem. Okay, I have used a different file. So it failed. Yeah, the failing was the most expected behavior. Now some systems might just directly run and some systems fail because for example Mac and Linux, they don't exactly allow you to use the secret key file unless it's secured. Right now this file is readable and writable. You can read or write into the system and basically abuse it, exploit it, change it. So a Mac will not allow you to use that file unless you secure it. So to secure it, you have to use this command chmod 600. It's inside downloads and it's node.js profile key.pem. So when you use chmod 600, whatever path you pass inside the pass next to it will make the file read only. Now it cannot be edited. So this command does not give any output, it just changes the properties of the file. Now if we run the previous command again, it will work. So it gave us some data, blah blah, and now we are inside our system. See, you can see that the basome at the date, because that is the username that I configured during creating the system, and node.js profile. So now we are inside our virtual machine. Okay, now this whatever I type here now will be running inside the virtual machine. If I type ls to list out what are the files available, nothing, it's completely blank because it's a new virtual machine just created for us. So here, first of all, let's make sure that our source code for the today's project is available. So what we're going to do is I'm going to go into the link that I shared with you guys. I'm going to run git clone here, and I'm going to clone the repository. So now if I do ls, the source code is available. So let's go into the source folder, and now node is not present here, right? Because to run this is a node.js project and it needs the node runtime to run. So how to set it up? As a cloud engineer, it's one of your roles to make sure that the environment is set up for the project to run. So if you go to the readme file of the project of the GitHub link that is available to you, there are two commands inside the cloud VM setup section. You only need to run these two commands to install node.js on your system. Like, yeah, on Windows installing anything is a headache, but on Mac and Linux you can install everything you want from your terminal. That's one of the beauty of developing, or doing software development projects on Linux, like Ubuntu or any Linux based system. So first of all, you need to paste the first command. This will go ahead and download the requirements for installing node.js. While that completes, let's copy the second command. This basically installs node.js. The first command downloads the files required. The second command installs node.js. Now this is not cloud native specific instructions. These instructions are existing here because today we are deploying a node.js project. If you would be deploying a Python project, your commands would be different. You would be installing Python instead of node.js. We install node.js, let it finish. Yep, profiler, cool. How long does it take to install node.js? This is weird. Cool, it did it, right? So now node.js is available. Now just let's make sure that node.js is available. We just need to run node version. So it is installed successfully. And when you install node, you also get npm. It stands for node package manager. Like if you have if I hope all of you have used Python. So if in Python, if you need a new package, all you do is write pip install the name of the package. Similarly, when you are doing a node.js project, it comes with npm, node package manager. It can install any package for you. So inside, now we are already inside the what do we call project folder. It has the package.json inside it, right? It has a list of all the dependencies that we require. So if we just say npm ci, it will install all the packages that we need. As a cloud engineer, again, we don't need to worry about the working of the entire application. We just need to know the right commands which set up the project for us. So we did npm ci to install the packages. Now we are going to run npm start. Okay, so this booted up the node.js server inside our virtual machine. So now there is something running inside our virtual machine. So let's go ahead and try to use it, right? Cool. So we are going to, so this was the public IP address which we earlier tried to access. Now we'll put 8080 into it and say register. Basically the same URL that we are trying before, but with a new IP address. Now you'll notice that this will fail, and it is supposed to fail because by default your virtual machine is a black box. It is a vanilla machine created by Microsoft Azure, and it is made available to you. But Microsoft Azure does not know on what port your software is listening, on what port you need to run your data jobs or anything, which port should be doing what kind of protocol, and nobody knows that. So you need to go ahead and update the network configuration so that your machine can now accept requests at port 8080, because that is what our server is using. If you want to change the port, you're free to do that. You can do that in the code, but we require port 8080, right? So how do we do that? To do that, we need to go into the Microsoft Azure portal again. Let's go to let's go to our home. From home, select all resources. In all resources, you will see today's machine that we have created. Node.js profile, yep. Node.js profile. Now, in with Node.js profile with the same name, try to find something that ends with NSG. So this is right? Energy Node.js profile NSG. So this is it. NSG stands for Network Security Group. This resource is administrating or controlling all kinds of network interaction with your virtual machine. Even your SSH is being controlled by this network security group. SSH is the way in which we accessed our system. This one. But right now we are inside the system, it is because of SSH. So here you can see all the network configurations that are allowed to your system. There are two sections, inbound security rules and outbound security rules. In inbound security rules, you can everything that you see in inbound security rules is all kind of networks that can send a request to your server or to your virtual machine. And outbound is where it can the server can send back requests. Normally server never sends back request. A server basically is there to serve. It can only get a request and only respond to a request. A server normally sends request if you're doing some kind of WebSockets. It's a complete different paradigm, right? We are not making WebSockets today, we are making HTTP requests. Cool. So yep, I am keeping an eye on the comment section. If you have doubts, please let me know. All right, so these are all the inbound security rules on your system, and let's just see what are the security rules currently enabled. There are SSH, HTTPS, HTTP, RDP. These are the four which we configured during the initial network security configuration during the location of virtual machine, if you remember. These are the different ports these allocations are running on: port 22, 443, 80, 3389. These are the standard ports for these protocols, right? And we don't see anything that allows us to send request at port 8080. Remember, our server runs on port 8080. But the network security group does not allow any request into port 8080, and that is a problem because we need to make sure that our port 8080 is available. Like, so now what is happening, the current scenario is our Node.js server is running. It is running inside the virtual machine, and it is listening for port 8080 from the inside, right? But port 8080 is not accepting connections from the outside. So even though it is being listened from the inside by our software, but the machine is not allowing connections into port 8080. So you can think about the situation like there is a tunnel. The name of the tunnel is 8080. On one end, someone is keeping place their ears so they can listen to some kind of requests. But on the other end, the other end is capped, it's closed, it's sealed off by the virtual machine. So even if someone screams from the other end, from the outside section, nobody on the inside can hear anything because basically it's capped, it's not allowing any connections to go in. That was the weirdest example I could come up with. So like I think you can visualize what's happening now. You are listening on one end, but sound is not allowed to enter from the other end. In our example here, the sound is HTTP requests. We want to make sure that we can accept or listen to connections from the outside. So to do that, on the settings panel, click on inbound security rules. Here you can add a new rule. So we don't want to restrict any kind of source. We will basically accept connections from anywhere. You can basically select on IP addresses. We want to be a little bit more specific. All IP addresses are allowed to send us requests. There are no source port ranges. Destination is, let's say, a virtual network, or you can keep it any. The service is custom, and destination port range. This is where the destination port would go into, right? This is where our connection would be going in. So let's say, and let's give it a name, Node.js application. You can even configure this source port range to be 8080, right? It works. So basically, only from port 8080, we are now allowing connections, and then we are going to add this security rule. Okay, is it empty? I'm going to use uh, okay, I want to black, basically 0.0.0.0 is the way in which we uh, allow everyone to connect. This will not restrict any kind of IP connections. Everything is allowed. The least secure connection ever built, the least secure configuration, but it allows everything, and that's what we need in a testing environment. We want all kind of connections to be reachable. Let's refresh the page. And yep, there is our connection, port 8080. Source can be anything. It accepts connections from all kinds of IPs, and the port is 8080, right? So now, and if you're wondering what this number is all about, this is priority. So let's say there is some kind of configuration that is clashing, or there is a collision between two rules. Let's say two rules are overlapping. In that case, the number with the rule with the highest priority will be configured or given edge. And this is a new configuration, and here we have port 80 enabled. So now let's test it out, but before we test out, let's start up the server. So now our server has started. It is listening at port 8080. So now we can test out this particular address. Okay, and this still doesn't work. One probable reason for that is we have basically restricted IPs to 0.0.0. For the purpose of testing, let's make it any, so that it's accessible to literally everyone. Any kind of resource can accept that. Save the changes, right? What is destination and destination port ranges means? Destination is where to what port of your virtual machine should your requests be redirected. Like once it enters into the network security group, on what port of the virtual machine should this request be made available? So when we say destination port to be 8080, in port 8080, this requests will be sent. And yeah, I think these were the configurations available. Yeah, destination. So destination can be destination is basically to what basically you have a resource group, right? There can be a virtual network, there can be an application security group, or there is a group of IP addresses where you want to redirect this requests that are coming. So whatever requests come to port 8080, let's say you want to send it to somewhere specific, then you can configure this. And then there is destination port ranges. So in our virtual machine, we want to send it into port 8080. So it goes with our current port address, or you can choose a range also if you want to send it into any one of the available ports. But our application only listens at port 8080, so we are going with 8080 today. And now I'm going to restart the server. Cool. and I'm going to refresh the page. That is actually weird. The application should be working now. Let me just delete and create the rule again, because I had like restricted the IP address in the first time. Give, give one moment. Cool. Let's create a new one. Let's go with the default setting. Let the source be any. Source port ranges is asterisk. Asterisk is a wildcard selector. It allows everything. Destination is any, and our port is 8080. Service is custom. Do not set to HTTP, otherwise you will be restricted, because port 8080 is only available on port 80. The HTTP protocol only redirects to port 80, because that is how Nginx or any kind of reverse proxy works. So we are going to with TC destination port 8080 today. The protocol is any kind of protocol should be accepted. Priority, and let's again give it a Node.js port. All right, and let's wait for the security rule to be implemented. Cool. So the protocol is now implemented. Node.js port 8080, and source is any. So it's accepting requests from any kind of client. A client, by client I mean right now our system or our browser is also a client. So I'm going to restart the server, and now let's go to the IP address, virtual machines, Node.js profile. This is the IP address, port 8080, register. Okay, so our application loaded. Now you might see that the style, the CSS, or technically the CSS files or the styling or the images that were previously visible to us have not loaded, because if you want to also serve some static content, the CSS, JavaScript, these things come in the static content. If you want to load those kinds of things, then those things should be dynamically loaded from a different resource, like should be hot linked. You need to provide the external URLs. Normally a server does not provide those details, so that is why it's not loading the styles, but our application is now usable, right? So this is the most basic way in which the most fundamental way of making your application making your application available online. Now to keep the project simple, what I did was I did not allow any. I was not using this CSS and HTML. Everything are available here. I've made it this way because it keeps the project simple. We didn't have to configure any external Microsoft Azure storage and any static content distributor like CDN. Content distribution network. We didn't have to do all of those setups. The project was an easy to set up within a 1 hour session thing. So if you want to extend the application completely and make it a backend, make it a completely scalable backend, then you need to make sure that these contents are stored using some separate cloud service. And normally also the server does not serve static content, right? The server is there for listening to backend API protocols. But I hope from today's session you got an idea that if you have any kind of backend project, if you have a project that works on your system, how do you once and it's tested on your system already, you can go ahead, and what are the steps you need to do to go ahead and deploy it on a cloud system. uh, Today we learned about Azure virtual machine, right? And on your system you can get the logs where you have SSH. You can get the logs of what page was requested for at what time, and those details. So I hope you got an insight how your future projects can benefit from it. And do you need to set outbound rule? No. For normally for a backend project, you don't need outbound rule. You need outbound rules in very specific situations where your server is actually a content distribution network. like if it is serving some static content. If you're using WebSocket is something that you must have used if you're into backend development. It allows you to work on how do I put this in words? So for example, the way a server works is, there is a server, for example the one we built today. A server never initiates a connection, okay? A server only responds to a connection. So let's say today, like the way we did it, we wrote an address and we hit enter. The moment we hit enter, the server gets a request. See, you can get it, you can see in the server logs, you get a get kind of request was sent. Get is an HTTP request, right? Get type, post type, patch, put, update, the REST API basically. So a get request was sent, and the server responded with HTTP 200. 200 means the request was okay, perfect. HTTP 200. So with HTTP 200, it basically stands for okay, like everything went fine. So a server just responds. You can already see in this kind of log that it got a request at this particular URL and it responded with okay, and the connection is closed. That is how HTTP always works. HTTP and HTTPS. But when you here you will never see that the server actually sends a request. You will never see that the server goes ahead and sends the client a request. That never happens. A server can never send something from its from it by itself unless it gets a request. It can only respond to a request. So there is another concept called WebSockets. WebSockets allow you to do some real-time data. Uh, WebSockets allow you to send some real-time data into somewhere. For example, I think I have a sample WebSocket example. If I can show that in the session, it must be in my drive. I hope I have not deleted the project. Yep. So this was a sample WebSocket project that I built, I think last year. What this allows you to do is basically here you will see that not only the user sends request, but the server also sends request. So here you can see that my camera is working. So the browser is capturing the camera, and it is sending the whatever is currently being captured from the camera, it is sending it back to the server. And the server is using some machine learning algorithm to find out where my hand is, and it's tracking the pen and sending back the coordinates of the pen back to the system. So what this allows you to do is, I just move the pen in front of the camera, and it will draw those whatever I'm in the way I'm moving the pen onto the blackboard. So it's like a virtual blackboard, like a magic painting. You move your pen, and the server will draw everything on your system. Now this is a typical example where server sends requests back to the system. Now this is the exact technology, WebRTC. It allows you to use WebSockets easily, and this is a library that allows you to programmatically define the rules of the WebSocket connection. So this is an example where you would typically have to set the outbound rule, because here WebSocket will be sending back 30 times in every second the current location of the pen that you need to draw. This is one example. I hope that answers your question where you need to set outbound rules. Okay. Are there any more questions, or we are good to wrap up the session? Will you also explain Azure Stored example? I can show you what is Azure Stored. It is easy to set up. I hope my screen is still visible. Uh, can so, um, can someone add the screen to this stage? All right, give me a moment. Cool. Azure Stack Edge, storage accounts, simple storage explorer, and you can use, like, there are n number, these are the storage services that are available to you. You can use one of these services to actually yeah, actually my screen is not visible and I cannot put it on the stage. uh, Yep. Oh, now it's visible, I guess. So yeah, you can use one of these services to use, what do we say, as a storage. Now, storage comes in not just Microsoft Azure, whatever cloud provider you're using. Everyone gives you an example of Microsoft Azure storage. Everyone gives you basically cloud storage, and all of these storage are expandable. So let's say you go with one of them. You, with time, you can upgrade them the way you want. And another example, another free tool that you can use for storage is called hot linking websites. You can find out best hot linking websites for images or static content, right? So you can use any one of these 6 websites. What you can basically do here is, let's say you go into one of these websites. For example, I can go into Imagebox. This will allow you to upload any static image and get a URL. I think it's working slow. Google Photos. We have Oshi. Let's use Oshi. Oshi looks good. Okay. So what Oshi allows you to do is okay, this is Imagebox. You simply upload an image. Let's say I upload a picture, and the moment you do that, you will get some configurations, and you'll just say start upload. Select a content type. Let's say it's to be a family safe content. Start the upload, and the moment the upload is done, you'll get an URL. Yep. You get an URL, and you can use this URL in any website, in any web page, to directly integrate this page anywhere you want to. So it's a free tool. It allows you to use your storage, and you can upload your files here, and you can directly use this URLs in your HTML code, so that your server does not have to send them, and this will be dynamically downloaded. It's a free tool. Apart from that, you can obviously use Microsoft storage if you have a really huge amount of static content. And this tool, this method of injecting URLs into HTML is called hot linking. So you can Google about this to learn more. It's called hot linking. Sorry, this is private comments. Okay, I need to log in with a account to actually type in comments. I should do that from the next session. Cool. So yep, I hope this session gave you some insights about how to host and dynamically make your future projects leverage cloud computing to make your projects available on the internet for everyone to use. And that will really give you an edge in your resumes, because you can describe your projects in 5 lines, but instead you just give a URL and allow the reviewers to use your project and get the experience themselves. That is a 10 times better experience. And on that note, we conclude this session for Microsoft Azure fundamentals. You are on mute, Shivlal.
Am I audible?
Yeah, now you are.
Okay. So thanks Divyasam for this wonderful workshop with the basics of Azure. And don't forget, guys, we also have some more Azure things for you. We also have Azure Quiz today. So link will be shared in the comment box so that you can sign in and you can register for the quiz. And thanks, Divyasam, once again for giving your time and expertise, sharing your expertise for this fundamental to share your knowledge on this fundamental of Azure.
My
And
pleasure.
Yeah, we also have a Discord community, so you can also join. The link is in the chat, so you can join the Discord community. We share all the sessions regarding to Azure, and share quizzes regarding to Azure, and more quizzes. You are on mute, Lakshmi.
You're on mute.
Okay, so our last, I'm sorry, my bad, guys. So a last announcement from my side. We have a quiz around 26 today at 8 p.m. We have a quiz in our Discord channel, and top 10 winners will be getting prizes from Microsoft swags basically. So do join the Discord channel and make your seat cuts reserved. So thank you, Devishom. Thank you, Sevlal. Thank you, Shubhendu, for being here. Thank you, Devishom, for speaking the session, giving your best insight about the Microsoft Azure. And thank you, everyone. Thank you. Have a nice day.
Thank you, guys. Thank you for having me. Thank you for